Okay, problem 49. So we have a parametric situation, and we'd like to find a couple three derivatives. Let's do the easy one first. Let's do dy dx. Now, dy dx, as we had noted before, is dy dt divided by dx dt. And if I want to say, what is the derivative of y with respect to t, I think I end up getting cosine of t. Everyone okay with that? dy dt is the derivative of y with respect to t, cosine t. So far, so good. Great. If I want the derivative of x with respect to t, I'm going to get 2t plus 1, and that indeed is dy dx, and it's a function of t. Part A is down. So far, so good. Let's go to the second one. What is the derivative with respect to t of dy dx? Well, it seems as though I have dy dx right here, right? And it's written in t's, isn't it? So this one, I'm going to, for this one, I'm going to go over here, and I'm going to say, well, I'll take the derivative with respect to t of cosine of t divided by 2t plus 1. I am going to literally plop that into there and take its derivative with respect to t. I think this is a quotient rule. Call me crazy.
No.
You're crazy.
2t plus 1 times negative sine of t minus
Cosine t
cosine t times 2
over 2t plus 1.
which is equal to 2t sine, negative 2t sine t minus sine t minus 2 cosine t all over 2t plus 1 squared.
I think in the book they left sine t out. They didn't distribute it, but it's
They just left it like here?
they just left it negative 2t plus 1 sine t. But it's the same thing.
Okay, I can deal with that. All right, are we satisfied with B?
Yes.
Now, on Saturday, when I was up with my father and my brother, I was doing this problem. And I seriously doubted my calculus skills when I hit part C. So if you think you hit part C and you're like, huh? You are not alone. You are in my company. Then I took a walk in the woods. It was very nice. And then I figured out what they were getting at. They tell you the clue is to use the chain rule.
Well, isn't that the whole chapter?
And it says, use the answer to part B. Well, the thing is, we use chain rule to calculate this part. So does that really count? Whenever we do a parametric slope here, we're using the chain rule. We're saying we recognize that dy dt multiplied by the reciprocal of that, which is dt dx, they cancel. The act of that canceling is the chain rule. And so I took my walk, and I came back, and I realized what they were getting at. Are you ready?
Enlighten us, please.
What is this saying? It's saying I want the second derivative of y, and I want 2 dx's on the bottom. All right? What is this thing that we just found here?
dy dx with respect to t.
It is, the thing that we find in part B is d2y dt dx. So here's what we want to find in part C. Here is what we've already found out in part B. How different are they?
One derivative of t.
This one here has a dt, and we don't want a dt.
Right.
This one here has 2 dx's, and we only have 1 dx.
Times dt over
how can we get rid of the dx and get, sorry, how do we get rid of this dt and get one more dx? How about we multiply this? How about we multiply it by dt dx? If we start with the answer from B, now what is dt dx? It's the reciprocal of dx dt. So if we start with what we have, negative 2, sorry, can't even write. We start with what we have, which is negative 2t plus 1. I'm so excited I cannot write. This is so terrible. Negative 2t plus 1 times sine of t minus 2 cosine t. Cosine t. All over 2t plus 1 squared. And I multiply it again by the reciprocal of dx dt. Dx dt is this, is 2t minus, or 2t plus 1. The reciprocal of that is 1 over 2t plus 1. Giving us a final answer of negative 2t plus 1 sine of t minus 2 cosine t all over 2t plus 1 cubed. And that's the final answer.
Oh, that's so much easier.
It was about knowing where I started and knowing what I wanted to get to. And what I wanted to get to had this on the bottom and that on the top.
How do we know that dt dx is 1 over 2t plus 1?
Because we calculated it right here. Well, we calculated dx dt is that.
Oh,
So what's the reciprocal of that? 1 over that. What do you think?
I think you are a mad genius.
I had the benefit of having a walk in the woods. It's obvious that because of the lack of a walk in the woods, you couldn't arrive at the same place.
Must be obvious.
That's exactly what happened.
All right? And by the way, that's what the answer is. Okay? All right. Let's close off the recording for 49.